Hi, I'm Matteo Romiti, research engineer from the Austrian Institute of Technology, and in this short presentation we will see what happens when spam meets cryptocurrencies. We will focus on sextortion and Bitcoin, and hopefully you will get curious about our research paper done in collaboration with Mazara from GoSecure and Thomas from VirusFree. Let's start.
So, what are we going to see in the next minutes? After giving you the context of our work, we will see how we process the data to extract useful information, and then we will see the results of our analysis. We will conclude finally with some takeaways in the discussion section. So, what is extortion? Well, lots of people have heard about the scheme, but here is an example. The message is that if you don't send the money to a Bitcoin address, the attacker will release compromising material that will probably ruin your life. Now, just by reading this email, it might not be easy to understand, but this is fake and the attacker does not have any compromising material. Overall, we blocked more than 4 million emails, and none of these emails received the intended user. At this point we ask, how do they operate? What are their relationship? Is it profitable? What can we or do we know about the spammers and the money? As you may understand, there is some data here that has to be processed and analyzed. And this is our pipeline, and everything starts from VirusFree that managed to collect spam emails containing strings like Bitcoin, BTC or similar, and they had a tailored spam filter for that. After that, we need to somehow categorize or classify all these emails, and luckily we noticed that they shared some common structures, and so we came up with a process that we called email bucketing, which allowed us to put similar emails into the same bucket. Despite this, it was not enough because not all of the emails were related to sextortion, so we had to look at these buckets and discard the unrelated ones. And in this was the manual classification process. Also, we noticed that some emails, despite being put into different buckets, had the same underlying message, or better, the same keywords. And at this point, we introduce a concept of campaign. And as we will see, a campaign is a set of emails that share the same keywords, even though they might be in different buckets. So here is a summary of our bucketing process, where we start with 4 million emails and we end up with 96 buckets related to sextortion only. More details can be found in the paper, but the method relies on the similarity of specific parts of the emails and on a filter that removes unrelated emails just by analyzing text and using parts of the text. As we saw in the previous slide, we ended up with 96 buckets, and here we have 2 examples of emails in 2 different buckets. As you can see, they share the same keywords, even though the rest of the message uses different phrases. By manually analyzing these 96 buckets, we concluded that we were dealing only with 35 different sextortion campaigns, and each using different keywords. And what are these campaigns about? Here you can see some examples, some keywords. Sometimes they are more specific, sometimes they are less, they are more general. But one thing to keep in mind is that none of them are true, and all these malwares were never installed on victims' computer. So the last and most important piece of information is related to Bitcoin. In particular, the Bitcoin addresses where money was supposed to be sent. Overall, we found more than 12,000 addresses from more than 4 million emails. And this is already telling you that these addresses were reused among emails, and that the attackers didn't make the effort of keeping track of which victim paid which amount. We also noticed that only 245 of those initial 12,000 addresses actually received payments. And by using the co-spend clustering heuristic provided by GraphSense, our open source tool for cryptocurrency analytics, we were able to link additional addresses to this extortion activity for a total of almost 500 addresses. This is the table that can give you an idea of which numbers we are talking about. You can see that the first and largest bucket contains almost 2 million emails, and it is in check. You can also see that the amount of money asked was ranging between 280 and 290 euros in this case, but you can also see that other buckets were using different currencies. You can also see the time period of the emails and whether the emails contained leaked passwords or not. And also the text similarity among emails in the bucket. One thing you can notice is that a specific campaign, for example, campaign A was using different languages. For example, campaign A is using Czech, but also using English and German according to our data. Let's now have a look at the results and what we learned from the data. One first observation we can make is that the spammers ask for higher or lower amounts depending on the language. We also know that spammers are sometimes aware of the victim's passwords as they include them in the email. But this is, according to our data, not influencing the amount that was asked. A second observation was that Bitcoin addresses were reused not only among buckets, but also among campaigns. And here is an illustrative example where we have 3 buckets represented by curly braces and 2 campaigns represented by colors, in this case black and gray. And you can see that address A1 was used in bucket 1 and in bucket 2, and also that the same address was reused among campaigns, so the black campaign and the gray campaign. This address reuse allows us to draw a financial connection between buckets and campaigns. If you extend this method to our entire dataset, this is what you get. You can find more details in the paper, but the bottom line here is that it is very likely that there is one single entity behind all these emails, as we can link them using the Bitcoin addresses and their transactions. Another interesting aspect is what are the revenues of such an activity. Here you can get an idea of the scale and the size of it, and on the x-axis we have the time, while the lines represent the revenues in US dollars, and you can see them on the right y-axis, while the dots represent payments in US dollars that you see on the left y-axis. And you can see that roughly we are around 1.4 million US dollars just in a time frame of a few months. Last point, we tried to see where this money was going, and despite our limited dataset of Bitcoin attribution tags, we were able to spot some exchanges, even though they received just a small percentage of the overall Sextortion revenues. So what can we say about Sextortion and spam using Bitcoin? These are the main takeaways, I would say. First, spammers do not care if you don't pay because they do not track your payments. And there is a correlation between price and language, but not with leaked passwords. The revenues are more or less in line with traditional spam, and all of these threads and emails are basically connected and linked to one single entity. And that's it for this presentation. Here you can find some links and references to our material online. I hope it was informative and interesting, and feel free to get back to us with questions or feedback. Thank you for watching.